Hello. This is Amit Suryavanshi, and today we are going to see the overview of the Cadence tool. So, basically, how we are going to open the Cadence Virtuoso. Cadence Virtuoso is an EDA tool. EDA means Electronic Design Automation. It is an EDA tool where we can design the schematics, where we can run the schematics, where we can analyze how our circuit is behaving. This is not only one tool, there are many other tools as well, but for many of the analysis, like for finding gain, how the input is behaving with respect to output, and many other advanced stuff, we are going to use the Cadence Virtuoso tool. So this is one of the basic tutorial where we are going to see how the CMOS inverter is gonna behave, like with respect to different W by L ratios, which is nothing but the or the different ratios for the PMOS and the NMOS, where the widths of PMOS and the widths of NMOS are going to be equal for one case, where and width of NMOS is going to be twice of the width of PMOS, and another case is like where width of NMOS is going to be width of PMOS by half. That is W by WN is equal to W of P by 2. So let's see. First of all, like we have to know like how we are gonna open schematic file and how we have to attach the libraries and all. So firstly we have to go to file, then we have to click on new, and we have to create a new library. Basic library is like where all our symbols, the basic PMOS and MOS symbols are gonna be created. So we have to click it on library. So we will not create a new library, but we will use the existing library attached to an existing library technology, and we will click on OK. So firstly we have to give a name. So just say a test. Let's write test. We have to click it on OK, and then we have to click on GPDK 90, which is related to the 90nm technology library. So we have to click it on apply, then we have to go for OK. So our library is created, and then we have to go and create a new cell view. Let us now choose the library which we have created. The name was test. Now since we are working on CMOS inverter, let's type CMOS INV, and please remember that both the options are being chosen automatically. They are automatically chosen before, but if they are not chosen, make sure that these are chosen before, then press OK. Yeah, so this is our cell view. Basically this is the area where we are gonna place our transistors and where we are gonna make connections. So just press the button P for choosing a component, or go to the create instance button. Sorry, not P but I. We have to click it on I, then we have to go for browse. Let's choose the GPDK 90. Yeah, GPTK 90, and then we have to go for PMOS, and then we have to go for symbol. Yeah, let's just close it, and you can see all the parameters are given here, like what type of PMOS and NMOS we have to choose. Then next we have to place it here. Similarly, we have to go and create another symbol, like we have to add another MOS, which is nothing but NMOS. Let us go and choose NMOS now. NMOS. Yeah. Since we are making the first case is like WP equal to WN, where our width of NMOS is not equal to width of PMOS. As you can see here, let me just zoom in. You can just press Control and the scroll button. Like press Control and scroll with your mouse. It will give you a zoom in and zoom out facility. So basically you can see the width of PMOS and width of NMOS both are 120 nm and 120 nm. So this is our first case, and then we have to go and make out connections. So the video will be lengthy. I will just go to the inverter where we have done all these things. Let me just open that. Okay. CMOS inverter. Yeah. So this is the schematic how it will look after all the connections. So basically, yeah. The one more important thing is like how we have to add these pins and all the things what you are seeing here, the pins. How you have to do that? Just click on create pin or just press P, and you can see you can add a pins here. Let us see now. We have to add firstly the input pins. Okay, VDD, VIN, and VSS are the input pins. Why they are input pins? Because VDD will be having the input rail, the VCC rail, which means the 5 voltage supply rail, and input is like where we have to give our input, and then there is a ground or VSS which will be connected to the NMOS at the source side. So okay, we have to write VDD space VIN space VSS. So now accordingly one pin will be created. First we will get VDD pin, then we will get VSS pin, VIN pin, then VSS pin. Okay, see VDD, VIN, and VS. Since I have made all the pins and the connections, how we have to make connection, now just let's see like how we can do the connection. I'm just deleting these connections. Yeah, so you have to go to uh, just go towards the narrow wire, and then choose the point, this red point, and then click here. As you can see there, you can see a marking, a rhombus kind of thing, where we have to do our connection. Yeah, this is a connection made. Similarly, you have to make all the other connections as well. And now you have to press save, save, and then check save. Check save is like basically it will see whether a loose connection is there or whether you have made mistakes and all. So let's see. Yeah, nothing is coming, which means our schematic is correct. Now if let's take a case where I have not made a connection to the VDD. Ah, now here one connection is missing. Let's see what's gonna happen. Check save. See, I'm getting an error. That warning. I'm getting a warning. See, I have made a loose connection, and it is also highlighted here. So this is how you have to make connections and do the same thing. Check and save. The warning will be vanished off. So now we have made a PMOS inverter. Now to test this PMOS inverter, we have to make a test bench schematic. For that, you have to go to, you just need to like minimize this window. You have to come here and then create a new and create a cell view. Now here you have to make a test bench schematic cell view and click on OK. So this is another new area. So basically now here we have to call our CMOS inverter as a symbol. How we have to do that? For doing that, mm, yeah, for doing that, you have to click on create, and then mm, create cell view for from cell view, and then basically this inverter, and click on OK. It's saying that already we have a symbol, but let's see, replace. So yeah, basically a box will be created where all these pins will be coming. So at the left side we will have all the input pins, and at the right side we will have a Vout pin, and then we have to click on OK. See, this is how a symbol will be created. But for our simplicity, let's create a symbol like from Selvin. Okay, yes. Ah. So at the left side, every time we will be taking an input. At the right side, we will be having an output, and at the top, we will be having a VDD, and at bottom, we will be having a VSS. Okay, this is how a symbol will be created. Mm, yeah. And this is a symbol. Next.